Last example we are going to look at will be an example of a perfectly inelastic collision, which means momentum is still being conserved, but there's a lot of energy loss. But the real thing I want you guys to remember, though, when we're doing these in terms of the way we're going to calculate these, is they stick together after they collide. So they are treated almost as a mass of a system and a velocity of a system. They move together, they move as one. So it's almost like they get morphed into one object. So blob A is traveling in free space at a velocity v, slams into another blob B, which is initially at rest in a perfectly inelastic collision. So they tell me they're going to stick together. If the mass of blob A is the same as the mass of blob B, and they stick together after the collision, which didn't really need to say because it's perfectly inelastic, but okay. What is their final velocity with respect to the initial velocity of A? So in this case, now we're looking for velocity, not mass. I'm not going to use our same drawing as before. I'm going to draw these out. This will be blob A. And let's have this be blob B. Doesn't necessarily matter, but we'll call this A, call this B. A is traveling with an initial velocity V, and B is stationary. It tells me it's not moving. So the way I set the equation up, though, for the perfectly inelastic collision has to be a little different. Now, momentum before still equals momentum after. That is still true. The momentum before, though, is treated as the momentum of the blobs separately, individually. So this would be the momentum of A plus the momentum of B. The momentum after is going to be the momentum of the system because they stick together. So the momentum of A, that's going to be the mass of A, the initial velocity of A. This is going to be plus the mass of B, the initial velocity of B. Then this is going to be equal. So I can think of it as I just add their masses, the sum of their masses. So this is going to be M A plus M B, their final velocity of the system. Okay, this is the thing I want to find, right? Well, what is M, the mass of velocity A? If they're the same mass, A and B are the same mass, let's just call each one M. So M is the mass of A. It's traveling with velocity V. We know B is not traveling anything times 0, 0, so that's just 0. Then mass of A, that's going to be M. Mass of B, that's also going to be M. They're just the same. We can call them whatever we want. And then this is going to be V final of the system. That's what we're looking for. This is just going to be MV equals 2M V final. If I divide it, I get that 1/2 the velocity is the final velocity. So the final velocity ends up being cut in half, which makes sense if I think of, I have a blob traveling at velocity V and it doubles its mass. Well, then proportionally its velocity is going to halve. And that kind of we can conceptually wrap our heads around.